All right, hello everyone and welcome to the course. This is Mohammed, and today is our fifth and last session of the DevOps Zero to Hero course. And today is June 7th, 2020. So this session is recorded. So if you have any questions, please feel free to use the chat or enable your microphone and ask your question. So for today's session, I will talk about the service mesh. After the previous sessions where we learned how to write some Go code, we learned how to write some tests, how to integrate our code and build a Docker image out of it and deploy it to Kubernetes. And in the last session, we learned how to build a CI/CD pipeline that allows to build our code, run the unit tests, and build a Docker image automatically and deploy to Kubernetes with just the pushing the code to GitHub, and everything will be taken care of by the pipeline. Today, we will move on to a very important part of the lifecycle management of our software, which is the monitoring and the management of the traffic of our application. So if you are deploying an application, you would like also to maintain it and to understand the health of this application. And this is where the service mesh comes in. So I will start by introducing what is the service mesh, and I will use Istio as an example of a service mesh. Then I will show you what are the advantages that you can get by using a service mesh in the microservice architecture and in Kubernetes world specifically. And after that, we will just wrap up. So let's get started by defining what a service mesh is. So a service mesh is used to describe a network of microservices that make up distributed applications and the interactions between them. So basically, if you have a distributed application, and so it is composed of different microservices, and you would like you'd like to understand how each part of this application talks to the others. How the traffic goes inside your application, because sometimes you don't even know all the parts of the application, but you would like to understand how the traffic works, how every component talks to the other. Is there any security between them? Which traffic is going to which component? What is the percentage of the success versus failure, and things like that. You would like also to have some tooling that will allow you to do that out of the box. You don't really want to focus on the non-functional features like monitoring and the observability part, but you would like to focus on your code and get something to help you with that. And this is where the service mesh comes. So one example of service mesh. So this service mesh thing appeared only recently. It is not a very old technique. It appeared after the microservices. And one of the known service meshes that started I think four or 5 years ago is called Linkerd. And there is a new trend, which is a new tool to be used as a service mesh, which is called Istio. This is an open source project that is led by Google, IBM, Red Hat that joined IBM as well, and Pivotal, I think, and some other companies that plays the role of a service mesh. So basically, Istio helps to reduce the complexity of setting up a service mesh for you. So you install this tool called Istio in your cluster, and it will allow you to have all the nice feature of the service mesh. It will allow you to get better observability of your application with monitoring and tracing and logging. It will allow you to do traffic management between your different containers and different versions of the containers. So having a service mesh is a complicated task, obviously. But Istio helps to reduce that because it allows you to do that in a very transparent way. It allows you to get all the benefits without having loss of headache. It is an open source, so it is possible for you to get a copy of Istio and manage it and modify it based on your requirements, especially for big companies. They can get Istio, then have a different flavor of it by adding or removing some parts or modifying some of the parts. And it allows you to get a very large number of features for free, especially for the observability, logging, telemetry, and policy management. It allows you also to add an extra layer of security between your services. Yeah, so some of the feature that Istio allows are automatic discovery and of services. It allows you also to do the load balancing, a very fine-grained load balancing mechanism for your different protocols being used by your services. It allows you to control the traffic with routing rules. It allows you to include some best practices like retries, failovers, and circuit breaking, fault injections. It allows you to test the resiliency of your application and how your application is ready for any issues that can happen in any service that is part of your distributed application. Also, automatic observability in general. It allows to detect any traffic in the cluster and build some nice graphs and logs and traces of your of separate components and also of the overall architecture of your application. It allows you to add an extra layer of security, and also it allows you to extend it. And if you have any needs that are not already solved by Istio, you can extend it to add them. All right, so how Istio works. So basically, Istio is really tied to your application. So it has two parts. It has the data plane and the control plane. So the data plane is related to your components. Imagine that you have an application composed of two services, as shown in this figure. So you will implement basically the service A and service B, and anything else will be automatically added to your application. So when you install Istio and you enable it with your application, so it will automatically inject proxies for each service that you have. So if you see a service as a pod, for example, in Kubernetes world, then Istio will inject a sidecar container inside your pod that will intercept any incoming traffic and any outgoing traffic from your service, and get enough data and add some filters and controls to get monitoring data, tracing, logging, and control it, add authentication and any security layer that you require, and also share this data with the control plane. So the data plane is composed of these small proxies that are connected to each other, and the traffic is always managed based on these sidecar proxies. So in the case of Istio, it is using a sidecar proxy called Envoy. Envoy is an open source proxy that is used by many other projects, and it is pretty successful proxy that allows lots of controls of your traffic coming or outgoing the pod. So this is the data plane, and the control plane, which is like the main part that will control the interactions between these proxies, is called Istio. And Istio is composed of different parts. One of them allows the discovery of the services based on the data provided by the proxies, and it allows to implement any traffic rules. So it will get the traffic rules and put them or propagate them to the different proxies of your services. So if you want to make any change So you will talk to Istio, Istio through the pilot, and pilot will allow to implement these rules, like by transforming them into a language that is understandable by Envoy. There is the Citadel component that is responsible of any control policies and any security aspect of Istio. And there is Galley that is responsible for transforming your requirements into something that is understandable by Envoy proxy. So the data plane proxies are deployed as sidecars, and they allow the dynamic service discovery and the load balancing. If you want to add TLS termination automatically to your services, it's the Envoy proxy that will do that. It allows also like the proxying of your services, so they will intercept any incoming HTTP or gRPC calls and interpret them and add any kind of filters there. Circuit breaking. So if you want to do any failure mechanism and any circuit breaking mechanism, you will this will be implemented in by Envoy itself. Health checks. So any incoming call or outgoing call, the proxy will detect how much time your service is taking, if it is returning a success or failure code, and same thing if it is calling an external service, it will do the same for that. So you have full visibility of that. Also, the proxies allows you to do staged rollouts. For example, if you want to do a canary release, you can have different versions of your service, and you can configure that the proxies to accept or to forward the calls based on some predefined percentage to some given version of your service, and this allows you to do different things like dark releases and canary releases. We will see some of these features in the next sections. But this is, we can also do some fault injections. For example, if you are testing the resilience of your application, imagine you have 5 services and one of them is very critical to you. So you want to test it, like how it will behave or how your application will behave if this service fails. Then you can add some fault injections to this service and see how the system will perform and correct your system to tolerate these errors, for example. And also it will give you some rich metrics because it is intercepting any traffic, so it allows you to monitor everything that is going inside your services. Yeah, so this is how what I was saying about the control plane. So it allows the service discovery and configuration and certificate management using Pilot, Citadel, and Galley, and every component of these has a pretty clear functionality. So Pilot is responsible of propagating the rules that you require to apply to your service mesh, and this by sending them to Envoy proxies. Galley is validating the user-specific configuration. So if you send any configuration, it will transform it to an understandable configuration by the data plane. Also, the Citadel is responsible for any aspects of the security. Any questions so far? Feel free to post your questions either by chat or enable your microphone and ask it. All right. Okay. Okay. So now I presented what Istio is, and I will just give a brief introduction to some main concepts that we will be using when I start the hands-on setup. So there are 3 main concepts that I want you to know that Istio uses to manage the traffic and expose your services and send any query to the right place. So Istio is using gateways. So a gateway is a component or a concept that Istio uses to expose something to the outside world. So if you are familiar with Kubernetes, a gateway is similar to an ingress in Kubernetes world. So it is basically exposing your particular service to the outside world and explaining how or which port is open and what is the format that you will accept and which host is accepted and on which port and protocol and this will be used in your service mesh. Gateways also can be used for egress for the outcoming traffic. So if you want to expose or to call something from outside of your service mesh, you can use the gateway as well. The second concept is the virtual service. So a virtual service is basically it is very, very important because you will be using virtual services to manage the traffic. So you will have a virtual service that will intercept the calls from the gateway and then decide based on the rules that you will specify where to send this particular call. So if you receive something on this virtual service, you have full hand control on what to do with the incoming call, and this is the power of Istio is that allows you to decide what to do with every single call that you are getting in your platform. Do you want to send it to this service, to a different one, to a new service or a new version that you are deploying? And without these services, you have a normal traffic management that is very close to what Kubernetes does, which is similar to round robin between the different instances of the service that you have. But with the virtual services, you have a better control because you can even specify some percentage of the traffic to go to this particular service, another percentage to go to the other. All right. So after the gateway, and you define your virtual services to decide where to go, and this where to go is basically described by a destination rule. So you specify, you can split your destination rules in different buckets and say that this is the first version, this is the second version, this is the buggy version, for example, and these define destination rules. So the virtual service is how you route your traffic to a given destination, and the destination rule allows you to configure what happens to the traffic for that destination. So in terms of order, so basically when you hit the gateway, then you go directly to a virtual service. And after the virtual service, there are some filters that you can apply. There are some rules that you can apply. And then you will go to the destination rule. And then in the destination rule, you can apply any configuration in there. So this is the order of things. You can also you can avoid going through the API gateway through the gateway itself. Because if you are inside the cluster, you don't need the gateway, but you will be talking between virtual services and destination rules. So there is a difference between there is a difference between virtual service and Kubernetes services. Virtual service basically is a rule that is created by pilot that is also propagated to the proxies. A service in Kubernetes does not have a physical existence. Like a Kubernetes service is basically something written in the nodes in their IP tables, and it does not have any real concept behind it. It is it does not have a physical existence. But the virtual service is a configuration that lives in the proxies, and it is also saved in pilot and propagated to the proxies.
Mohammed,
yes.
Destination rules, destination rules, gateways, and virtual servers are contained in the proxy.
So the gateway it is not contained in the proxy. So it is a separate component that is defined by Istio, but the virtual services and the destination rules are.
Okay.
So they are defined by pilot, and they are propagated to all the proxies. So any proxy knows these definitions, but the gateway itself is a separate thing because it is not related to your to a particular pod.
So the gateway is the entry point of the flow.
Yes. So imagine that you have a Kubernetes cluster. You deploy your service-based application in the cluster, and you want to expose it to the outside world, outside your Kubernetes cluster, or to a different namespace in the cluster. Then you need to specify a gateway that will allow the incoming traffic from the outside or going to the outside. So it is incoming or outgoing traffic. But inside
the gateway is needed whatever you need. You're going to use a serverless mesh or not. You need a gateway.
No, you don't need the gateway. You don't need the gateway if you don't want to expose your service outside the Kubernetes cluster.
Yeah. Okay.
So the gateway is needed only
if you want to expose it outside. You need a gateway.
Yes, you need a gateway. Okay, so any other questions? Otherwise, I will start the manipulation, and we will basically, like in this hands-on, we will deploy Istio, and we will deploy an application and see the benefits of Istio, and this will kind of explain many of the aspects that are until now they are just theoretical, but we will put them in practice.
Mohamed, j'ai peut-être dans les derniers TP, on a fait un gateway ou pas? On était juste dans.
No, so gateway gateway is a specific term for Istio, but the equivalent, the closest equivalent in Kubernetes is the ingress. We did an ingress in Kubernetes.
Ok, on a fait quelque chose d'équivalent, mais on n'a pas utilisé le même terme, c'est ça?
Yes, it's not the same. Yeah, because ingress in Kubernetes, it allows you to describe everything. So it allows you to describe the entry point where your traffic will be hitting, and also where to send the traffic to. So you'll specify directly the service where you specify it. But in Istio, they have a nice decoupling of these things. So you define where the traffic is coming from. Then you use the virtual services to say that I am accepting the traffic from here, and then I will use a different thing, which is the destination rule, to send the traffic. So you have different ways of control in Istio. But the closest thing to a gateway is ingress.
Ingress, c'est le web service ordinaire c'est le serveur web qui est utilisé un petit peu partout, c'est ça?
So it is. So ingress is a concept in Kubernetes that allows you to expose a particular or many services to the outside world.
Okay.
So, for example, there are different implementations of ingress. One of them is
excuse-moi, moi qui m'ai trompé. En fait, j'ai confondu ingress avec Nginx. Je mélange tout. Pardon.
Yeah, and Nginx offers one implementation of ingress.
Ok, c'est une implémentation of ingress, d'accord.
Yeah, they offer. So Nginx has different functionalities, but one of them is an ingress controller. So it allows you to create ingress instances.
Okay.
All right. So so for first thing, we will install our Kubernetes cluster using Minikube. So here I'm putting some extra memory just to avoid having the system to crash. But normally it should work with 4 gigabytes of memory, or probably less, because the latest versions of Istio they are trying to reduce the overhead of the different components and reduce it to a very small value. So like the latest version was released, I think last week or just a few days ago. So, and it is 1.6.1. So this is the one that we will be using. So let's start by installing our Minikube. So as you know already, so starting Minikube will allow us to create one cluster with one node, that contains everything for our Kubernetes, but it allows to test almost all the features that that Kubernetes has. Yeah, so here I specify that the minimum required is this amount of memory, but just for me, I know that I have enough memory, so I specified this this value to avoid that. So if you are running the same demo in parallel with me, you can move on to the next section where we need to download Istio. So in order to download Istio, you hit this. You do this curl, and it will download the latest version, which is 1.6.1. So for me, I already did that, so I will not repeat the same thing, but it is really straightforward. So just download it, and you will find yourself in a folder that contains all the needed things, and it contains basically the binary that will be running, since Istio is written in Go. And it has a binary. So if you see this bin, so you will find a binary that you can execute. And personally, I prefer to add this binary to my path in order to be able to use it from any place. So I just modify my my bashrc profile, and I added that. So if I show you, I can go to my. So I'm using a different. I'm using Zesh instead of Bash. So so here I'm specifying, I'm adding Istio binary to my path. So you can do the same basically. Otherwise, you can add that temporarily using an export like this, and you will be able to use it in the same window as long as you you don't close it. All right, so now I have my my Minikube is up and running. So let's test that. So I don't have any pods. I don't have any Istio namespace. So now I can apply. I can start Istio, and Istio offers different profiles, and for the benefit of a demo, full demo, they offer a profile called demo, and this has like the minimal set of features with some limitation in terms of resources. So you can run it easily in Minikube, and it comes with the different features that that Istio offers. You can read a little bit in the Istio documentation. They have different profiles, and also in this folder that we downloaded, there are different profiles. I think here manifests. Yeah, so you see the profiles folder there. You can look at that, and you can see that there is a default profile, a demo profile, a minimal, preview, and remote. I will use the demo profile for this this thing. And if you look at the at any one of these profiles, so it is basically describing some Kubernetes deployments. Let's look at the demo one. So it is basically deploying. If you look here, so it is deploying an operator. And it is describing what should I put in this operator. This is an ingress gateway with some policies and some configurations for the different components that we talked about. For example, the policies, this one will go to the Citadel. This one, for example, will go to Pilot, and so on and so forth. And these are some add-ons that we will see that will be enabled by default for our demo profile. So this is basically the configuration that that we will apply. Yeah. So let's start this and see. All right. It might take a few seconds to start the different containers. So once we have Istio enabled, there is a feature that they have in order to automatically inject the sidecars. So remember the small proxies that we will have running with our pods. we need to inject them for any service in order to be able to get the benefits of Istio, and we can enable that for a whole namespace by labeling it by this small label saying Istio injection enabled, and automatically any new pod that will start in this namespace, it will have the sidecar, which is a pretty small footprint sidecar container, but it will allow us to have lots of benefits. So I believe it is really worth having that, especially in large scale projects where you want to get all these the benefits that we will see together. So, okay, so it seems that Istio is
pour mieux comprendre, là, ce que tu es en train de faire, c'est en fait, il y a des profils qui existent déjà. Tu as choisi le profil démo. En fait, les profils te permettent de décrire des règles. Plus ou moins, ils contiennent quoi, des services.
They contain a description of flavor of Istio. So how do you want to install Istio? What are the components that you want to enable? For example, here it installed Istio, core installation, Istio-D, egress gateway, the ingress gateway that will allow us to create gateways in the future. And the add-ons, and the add-ons are the ones that we will be using for monitoring, logging, and tracing. Yeah, so basically it is a description of how to install Istio itself.
OK. Chacun, il peut créer son propre profil ou
exactly. You can either start by a default configuration, or you can take one configuration and make the changes that you wanna do. Because any part of this, for example, if you don't want to use, let's say you don't want to use Prometheus for your monitoring, you have a different way to do monitoring, then you can use that way, which is very easy to integrate with Istio.
Okay, merci.
Okay, so let's see if we got. So we see here that we got a new namespace created called Istio System, and we can get the pods in this Istio System namespace and see what is being deployed. So here we see that there is Grafana deployment being added. We will see how Grafana is being used to visualize the monitoring data. There is the egress and ingress gateways. These are used to enable incoming and outgoing traffic based on gateway that we talked about. Istio Tracing is basically used for distributed tracing of your application. We will see that in details as well. And this is the Istio-D. This is the main control plane part that has Pilot, that has Citadel, and it has Galley as well. So this is the main component of Istio that allows the management of your of service mesh. Kiali is a tool that is used to visualize your service mesh. We will see that in details as well. I'm a big fan of Kiali. And Prometheus is used to monitor, collect any monitoring data. It has a time series database, and it allows kind of a very large scale way to collect monitoring data about your cluster, about your service mesh, about your specific components. So we will see all of these. So you see, this is what was defined in the profile demo. So if we change the profile, we might see different components changing based on the profile that we will specify. And this is what makes Istio running right now. So now we have Istio ready for us to be used. The next thing, I will enable the sidecar injection here. So on since I'm using the default namespace, I will enable it with this tag. It's called Istio injection enable. So if I do now describe my namespace default, I should see the label this label Istio injection enabled. So now any deployment that I will apply in my default namespace, you will see that it will contain, instead of one container, it will contain 2 containers. So we will see that right away. So now, okay, so like in order to benefit from this course and learn many features of Istio, I use the demo application that they have, which we don't really need to understand a lot about how it is written. So this is one of the advantages of Istio, is that it will give you visibility of the application, even if you don't really have any prior knowledge of this application. So the application is kind of a polyglot application. You have different components with different languages and different versions. So you have a product page that will allow you to present products. And this product page is written in Python, and we don't really care about the language. Just to show you that it is independent of the language, you will get the same features out of Istio. This product page is calling a service called details. It is written in Ruby, and it is calling some review for any product. We will get some reviews, and we have different versions of the review. We have 3 versions actually. One of them doesn't call the service called ratings here, and 2 of them they are calling the rating service. It is a service written in Node.js, and it returns a number of stars for the rating of the service. And review 2 shows these ratings in black, and reviews 3 shows these ratings in red. So this is all what we need to know for now about this application. It is a distributed application. It has different parts with different languages, and we will see how Istio will help us to understand and to manage this application. Okay, so we have the YAML files of this application inside the folder that we downloaded for Istio. So you can take a look about the content of this application. Let's start by applying that, and then we'll take a look. Okay, so by applying this, you see that there are different services. Only the normal like normal deployments are being created. So let's see what's happening. So you see that every component or every service of these applications are getting this pod initializing state. So in this pod initializing state, it is somehow Istio is trying to inject the proxies. And you see that all of them, they have this 0 out of 2 that are ready, because normally this application is composed by 1 container per service. But now we are seeing 2 containers per service. One is the real container, and one is the proxy. So first thing is integrating getting the proxies being added, then started, and then starting the application in order to get the full view of this application. In the meantime, let's take a look at the content of this file. So I didn't make any change to this file, so you will see that it is a pretty simple Kubernetes configuration. So for each one of these services, you will have a service account, and a deployment. It is pretty plain Kubernetes. There is nothing related to Istio here. I didn't add any Istio rules or anything to that. So this is a normal deployment, a normal service. Same thing for the ratings. So we have one service account, and 1 deployment. Nothing extra, nothing fancy. It is a plain service. Same for the reviews. We have 3 versions of the review service, and all of them, I don't have any specific configuration for Istio. It is a normal deployment that will be used as you write your normal Kubernetes things. Okay, so now our components are up and running, and you see that every one of them has two components. So if I do kubectl describe, for example, for one of them, let's describe this details, for example. you will see that it has some Istio configuration that was automatically added. And you see this is the configuration for the Istio sidecar. You see that there are lots of configurations that we don't really need to worry about, because they are automatically added for us, and we will only see the benefit out of it. So for each thing, we will have this proxy. This is an Istio proxy, and we will have the normal container that we deployed for this application. So this is automatically added because we added the injection to our namespace. So for every namespace, if you enable that, the pods will get the Istio sidecar injected automatically. All right. So okay, so now we want to see this application. So the first thing, and this is a first configuration. This is the first Istio configuration. We will create a gateway for our application to be able to access it from our browser. So same thing. The configuration is already in our folder that we downloaded. I will let's look at the content of this gateway. So basically, it created a gateway. It is very close to the normal ingress. So it is saying that I want to open the port 80, the port HTTP 80, as my gateway for any host. So anybody that will try to connect to the port 80 in my Minikube IP, then he will be allowed. And after that, after defining the gateway, we need a virtual service. So for this virtual service, I'm saying that I need to accept anything coming from this gateway that has this URI in the end. I need to send it to this service, to the product page. So this is one of the services that I have, and it has the port 9080 open. So anything that is coming that will respect these rules, product page /static/login/logout/API v1 products, I will send it to my product page service. So this is only what it gets to expose my my application. So it is basically exposing only the product page as you see here. So now in order to be able to access it, you remember in Minikube that we need to enable the ingress support in order to be able to use any ingress functionality. And since Istio in the backend is using somehow this ingress, we can look at that and access our service. So since we are only in one node, we need to understand that there is a kind of way of transforming the ports that are coming. So we are exposing the port 80, but in reality, Istio is using a node port to allow us to access the the service. So you see here this ingress gateway. So it is a normal ingress that is implemented by Istio, and here you see that the port 80 is in reality transformed to a node port. So we should be able to use this node port in our configuration to access the product page. So here I put that in the explanation in the platform here. So this port will change from one starting to another, and same thing for Minikube IP. So if we take Minikube IP, combine it with this port, and we open the product page, then it should show us the service. So let's try that. So this is the port, and you remember that we said that we will anything that will hit the product page should be sent to the product service that we have. So let's get kubectl kubectl get services. So we should see that there is a product page service that is opening the port 9080 as described in the gateway and the virtual service that we created. So anything hitting this address will be sent to the product page service, so which is showing this interface. So let's understand this interface. So basically, it is getting the details from the details service. So if I go back to here, so this is the details service. So it is sending this part of the interface. All the interface lives in the product page, and the reviews and the ratings are coming from these components. So the reviews is coming from one of these, and right now it is doing some round robin. And the ratings is coming from this service. So if I start refreshing, I should see different variations of the review service. One of them is in black, one of them is in red, one of them doesn't use the rating at all. So now I don't see any ratings. Any questions so far?
Okay.
All right. So until now, we didn't use a lot of Istio except the gateway, which is very close to the ingress. It is only exposing our service to the outside world, but nothing fancy until now. Okay, and now we will start the nice things. So one of the features that Kubernetes allows is the very strong observability experience based on different components that we specified in our in the demo profile. One of them is Kiali. I will show you how Kiali allows you to visualize your service mesh, and you can understand many things without even a prior knowledge of the application and the specifics. You can look at Kiali and understand which component is talking to which component with which percentage, and if there is any issue, you can detect it using Kiali. We'll also see Prometheus and Grafana, how Prometheus is collecting monitoring data about the service mesh, and how Grafana allows us to build on top of this monitoring and build some visualizations and nice dashboards to monitor our application. We'll see also Jaeger for the distributed tracing. So if you are using your application and there is any issue or latency, like your application is taking so much time to respond, then you can go deep and see the traces of your calls and see how many jumps you are having inside your application, which service is taking the most time to execute, and then decide if it is normal or not. So let's imagine that in this application you are seeing that like the review service is taking 7 or 8 seconds, then this is not normal. So you need to fix that particular issue. And this can be detected very easily using the distributed tracing. So in order to be able to see Kiali, Prometheus, Grafana, and Jaeger, we will need to create gateways also to expose them. And in order to do that, so I will be applying the same thing here. So I will create a gateway for each one of them and create a virtual service to say that any call coming to that gateway, I need to send it to the particular service that I have. So if I do kubectl get services in the namespace, in the Istio namespace, you will see that I already have services. So yeah, let's start this. So system, Istio system. All right. So you see that I have the Kiali service. I have a Jaeger service. I have tracing, Prometheus, and Grafana services. So all what I need to do now is to enable them to be exposed to the outside world. So for every one of them, I will create a gateway to say that anything coming to this address, to this host, send it towards this virtual service and send it using this destination rule. So basically add some rule to this destination. I will repeat that for all these 4 services, Kiali, Prometheus, Grafana, and Jaeger. So I will use this particular domain that I don't own. So I will be doing some changes to my Etsy host just just for this experience. But in a real environment, you will use your own domain if you have one, instead of modifying the etc hosts. So let me do that really quick. So I will export that, and then it is just if you are following, just copy and paste this until the end of file for each service, and you will see that it will be exposed. So now I have the gateway and virtual service and the destination rule for Grafana. So Grafana should be exposed now. I will do the same thing for Kiali. Same thing for Prometheus. So now what I'm doing is basically exposing the services. The services themselves, they exist already, but now I'm only exposing them with the way Istio allows to do it, using the gateways and destination rules and virtual services. So now I should be able to see Kiali at this address. I need to check that the address, because this address is my domain name, and this is the HTTP port that I use it here. So it should be the 32311 port that I used previously, that I got from the Istio ingress configuration. All right, so a small change, a small tweak to the etc host. So I need to do that. So Minikube IP, I'm on 24 now. I need to make the change to etc host, just because I don't own the domain. So I need to make this this small tweak, just to make my machine think that I have this domain and I'm referring to it. All right, and now we are ready to do that. So I will take this address, and let's start with Kiali. And the port is 32311. All right, so this is the interface of Kiali, and with this demo configuration, we can use admin as the user and password. And here we go. So we have this nice interface. So you will find yourself with a default view that allows you to see how many applications you are seeing in each particular namespace. You can filter that based on namespace. You can choose only to see the default namespace. You can do different filtering. A very nice feature of Kiali is the visualization of your service mesh. So let's select the default namespace and see how it is visualizing and how accurate is the visualization of my service mesh. So you see how accurate it is. So basically, it is reflecting exactly what I have in the diagram that I showed you. This is without any knowledge. I didn't give Istio any information about my application, but still it detects, since I started that, like I did this refreshing, it detected automatically that I have a product service that is calling with the version V1. It is calling the details, and it is calling the reviews. And reviews has different versions, and it is also calling the ratings with V1. So this is automatically done, and you see that I have this this gateway in front to expose my service to the outside world. I can. There are some nice features here. I can display like the response times, the request percentage, for example. Let's say we want to see the request percentages here, and I want to see traffic animation. Let's generate some load. I'll just refresh a couple of times, and we can go here and see. So let me try. Okay. So you can see how the traffic is going inside your service mesh. I think this is like a very useful feature. Imagine that you are joining a new team and they want you to understand if there is an issue in your application and you don't really know all the details of, about the application, then something like this will give you a nice diagram that that explains how the traffic is flowing through your application. So this is a first advantage of using Kiali. So you understand that you see the traffic and you see some monitoring aspect. Let's say if I select this particular service, the review service, you can see what are the queries, if anything is happening, anything good and bad. You can modify the time. Let's say this. I'm looking at the last 5 minutes. If I generate more stuff here, you will see that the traffic is going like 39% to V1, 33% to V2, and 33% to V3 here, which is pretty useful. Any questions? So yes.
Mohamed, bon, je vois c'est quelque chose de très intéressant. Juste ma question, si j'ai deux services déjà déployés dans mon cluster Kubernetes, par exemple, mon équipe, et après j'ai installé Istio, comment je peux faire intégrer Istio dans ces services? Est-ce que si j'ai fait un kubectl update, Istio va être intégré automatiquement dans ces services?
So is Istio, so when you install Istio, you need to enable the injection of the sidecars. So once you have the sidecars injected, then you will start seeing the benefits. So when the sidecars will be injected is if you enable a namespace with the label that I already created, which is Istio like injection enabled is true. Then whenever you restart the pods that you have, they will get the injection happening. So imagine you have service 1 and service 2 already deployed. You install Istio, you enable the injection in the namespace, then you just restart one of the pods. It will get the update. It will get the injection of the sidecar, and you will start seeing it here. Same thing for the second service. If you restart it, then it will get the Istio sidecar.
C'est bien, excellent, merci. Donc, pour l'injection, je dois spécifier les namespaces.
So you are not forced to do so. So if you specify the namespace, it means like any deployment, any pod that will happen in that namespace, it will get the sidecar injection. If you don't want to do that, then you can do that specifically per pod. So you choose the pod, and there is a way to say, inject the sidecar only for this pod. So it is a choice. It is up to you to choose either to enable it for all the namespace or for a particular pod.
Est-ce que l'Istio lui-même comment dire, ne consomme pas beaucoup de ressources? Par exemple, si je l'active en global pour tous les namespaces.
So the data plane, like the envoy, the sidecars that will be added are very tiny. They don't really consume lots of resources. Let's say let me show you. For example, let's take the example of this one. Let's see the description. Oh. Yeah, so let's describe this pod and see. So all right. So these are the resources that are being added by Istio sidecar. It is 10 milli like CPUs and 40 megabytes of memory. It is very small.
Okay, excellent.
It's really small, but yeah, but you still have the Istio namespace, but that part is set up only one time, and it is also not that huge, and you can configure it based on your requirements.
That's amazing.
Yeah, it's very useful. All right. So what else can we do with this with Kiali? So I can go deep here in one of the services. Let's take this service. So we can see a smaller view of the graph related to a particular service. And here I will talk about this later. There are some actions that I can do from this interface, and also I still have the network visibility, like what are the real endpoints behind that. So what is the reviews 1 and 2 and 3? Where do they live? What are the endpoints that they have? I can see the traffic that is coming and where it is going. So inbound, so I'm getting the calls from the product page and I'm sending calls to the review page. Yeah, I keep refreshing here because I specify the last 5 minutes, but I can increase that to the last 30 minutes. Then I can see the inbound metrics. So I can see what are the metrics that are coming. So what is the request volumes and how many operations per second I am getting at any particular time. I can specify that by destination or by source. What is the request duration for each call that I'm getting? What is the response size, the request size? These are all really valuable resources that you need in order to investigate and troubleshoot your services. A very important part also is this traces. So you can see the trace for each particular call that you are getting. But you will get into the details of the tracing because this is coming from another service, and you will see that the other service is called Jaeger, and we will see the details of the tracing. But you see that in Kiali, you are getting lots of data, and you can do many things that you will see later. But only like the graph visibility of your application that you can fine tune based on your requirements. It's really valuable for in my point of view, and you can change the way of you visualizing the graph that you have. So they have different ways of visualizations, and you can have different graphs. So you can use, for example, this service graph, so you don't really worry a lot about the versions. Then your application is composed of a product page, details, reviews, and ratings. But you know that reviews has different versions, but here you don't really want to see it. You can do that as well. You can have this workload graph, and it doesn't really show how these are collapsed into a particular service or not. You don't really care about that, but you care more about the pods that you have. You can do that. One of my favorite is the versioned app graph, because it gives you if there are some related services, it will put them in the same box. Any questions about Kiali?
Okay.
All right. Yeah. Okay. So the next thing is Prometheus. So let's look at Prometheus. So Prometheus. So it will get the same address, except it starts with Prometheus. Let's look at Prometheus. So Prometheus is a monitoring tool. So let me jump in. So, okay. So I showed Kiali already, and now we have Prometheus and Grafana. So Prometheus is a way to monitor your cluster, and it allows you. So it has a time series database to save the data, and it allows to scrape your monitoring data from different sources. So you specify the source, then you add it to your Prometheus, and it will continuously monitor your cluster. So if you open this, you will see this is the dashboard of Prometheus. You can specify alerts, you can build graphs, and you can see the status of your cluster, like what are the targets, where are you collecting the data from. So this Prometheus is set up to collect the data from these places. You can see if you have any rules. So there are no rules here. The runtime and build configuration for your Prometheus. Service discovery, what are the services that Prometheus is aware of. And here you can create alerts, and you can use Prometheus query language in order to collect the data. So, for example, here I have a very good monitoring tool, like document that I use regularly. For example, if we want to know the container CPU usage, if it is recorded by Kubernetes, you can look at that. For example, here it will show us for the different containers that we have. we can see how much CPU is being used at any given point of time. So you can do that. You can use any metrics. So there are many metrics here. So if you start typing, it will show you what are the metrics that are being collected by Prometheus. For example, you can see the API server. This is a Kubernetes API thing. If you look at that, you can see what is the count of the rejections of the API server for any admission control webhooks. You see that I got only one, and yeah, so there are lots of metrics that you can see and build graphs out of it. So it is a pretty powerful and scalable solution. Now in the Kubernetes environment, I see that most of the people are using either Prometheus or a modified version of Prometheus for their monitoring. It's a huge successful project. I think it is an open source project, and it is very successful. You can look at the different metrics. You get a lot of metrics that you can look at and get the benefits of the monitoring. This is part of the visibility or the observability of Istio that you can get for free without any big effort. Any questions so far about Prometheus in particular? Okay, so Prometheus itself is basically collecting. Go ahead. All right. So Prometheus itself is collecting monitoring data, and you can visualize them, but it is still a pretty simple way of representing things or visualizing them. But there is a better way to do it, which is Grafana. So if we jump to the Grafana dashboard, we can see that we have lots of nice visualizations. So Grafana is basically a tool that allows to build visualizations out of some data sources. So in our case here, the data source is Prometheus. Prometheus is collecting the data, and Grafana can allow a nice dashboarding for this data. So let's say so let's jump to Grafana here and see what do we have. So this is the Grafana dashboard. So Grafana allows you to basically create dashboards and create folders and add panels and add users. And but the main thing is creating dashboards and visualizations. So if we jump here, we can see that Istio already created some dashboards for us. So we can look at any of them. So I will, for example, jump to a service dashboard and see. So let's generate some load first in order to be able to see some data. So here I'm just refreshing the dashboard. I can just sign in. I'll sign out, refresh. So just generating some load there, and you see that that I can already I can see some loads there, and I can specify what is the service that I want to look at. Let's say I want to monitor the product page service or the rating service. Let's see if I'm getting enough data. This is the rating service, so you can see the client request volumes. You can see the service request volumes and the success rate of your services. You can specify by namespace. You can choose either to see the client workload or the let's say we want to see only, let's see all of them, or we can see only default here, the namespace. So you can specify like many filters in there, and you get all these nice figures. So if you jump in any of these, they are based on Prometheus queries. So you can create, for example, let's create one new dashboard. So these are by default offered by Istio. You get all the workloads monitoring data. This is very helpful. For example, if you want to see if there is any failure, you can start seeing it in here. For example, if you want to see the request rate or the success, the incoming success rate here, for example, this is any response that is different than 500 response, it is supposed to success. You can see that. So now we are in 100% success rate, which is the objective of any application to hit that. But you start seeing any issues, you can detect it here really quickly. So let's say we want to add another dashboard. We can add a query, and we can use Prometheus as our data source. And I will use the same metric that I used before. So let's say we want to write this thing. So you see that it is showing a very nice dashboard, and you can modify the type of this dashboard. So I don't want to see a graph, but I want to see a gauge, for example. So you can say that it will allow you to choose between one of these nice visualizations. If I want to see a bar or a heat map for my service, so it depends on the monitoring type that you want to do. For some of them, having a graph is not enough, but you would rather see a heat map or a histogram or something like that. Then Grafana allows you to do that in a very nice way. Any questions? All right, so yeah, so this is like so we saw Kiali, we saw Grafana and Prometheus, and now I would like to take a look at the next thing, which is the distributed tracing, which is also very important in your distributed application. So I will jump in and use here. I will just put tracing and same stuff. Leave. Okay. So here, this is the interface of Jaeger. So let's generate some load just to be able to see the traces. Sometimes it takes few traces before starting the to show the data. All right. So let's say we want to look at the product page, all of them, and find traces. So you see how many like the different calls that I did with the duration of all of them. So every one of them, how much time did it take to return? So I have 20 traces in this example, and for each one of them, I have I can see them here. Basically, they are identified by some identifier. So you see here the trace is having this ID. And if I open it, I will see how the time is spread for each call that is happening. So in the beginning, you see how much time was taking in the gateway. This is the total time, because the first thing that we are hitting is the gateway, and we will then start hitting the different services. And once I have a response, it will go through the gateway as well. So this is why you see that this span is the overall call. So this is what I'm seeing, the real time that I'm seeing since I hit refresh until I get the answer here. And inside, you will see, you will start seeing the small calls. So here, this is what's happening in the product page. So first thing, I hit the product page, and it is taking this amount of time. So it is taking, I can see the overall time, but you can see that how much time it is taking. Okay, let me review that. Okay, so you can see here. All right, so it is taking 45 milliseconds. And in these 45 milliseconds, if we want to understand how this 45 milliseconds was spread across the different other services, I directly understand that the product page is my entry point. Then it is calling this details. So first thing, so this is what it is passing inside the product page first. Then it is calling the details service, and the details service is returning within 2.91 milliseconds. So it is pretty fast. After that, I go back to the product page. Then I call the reviews page, the reviews service. So this time is taken by the review service, and here the review service is calling the rating service, and the rating service is taking 36 seconds. So you can see in an easy way, like if a service is taking more time than what is expected, you can see that really quick here in this distributed tracing dashboard. So just for your information, in order to have the distributed tracing, there is a feature that you need to enable, which is the header forwarding. So this trace is collected basically based on an ID, on a trace ID. So if your services are not aware of these IDs, then there is no way Istio can do it today if you don't specify, if you don't forward this ID. So this ID is created by the gateway. This 2CD, it is an ID specific to every session. So it is created in the gateway part. So whenever a call is arriving, it will get added as a header. You need to forward this header all over the place in order to be able to follow the tracing. So this is what gives you this visibility, because this header is forwarded from the gateway to the product page, from the product page to the details, from the details to the reviews and ratings. And this is how Jaeger is kind of creating all this this graph. It can get really complicated if you have many services, but it allows you to understand exactly what's happening inside your application and services. Any questions? All right. Okay, so this is basically what I wanted to show you related to the observability, and now I want you to get some time for the traffic management of the mesh. What are the features that allows me to do traffic management? What is traffic management basically? So yeah, so for observability, it is basically Kiali, and Kiali allows to combine all this data together, because if you look at the graph here and if you go to the details of any service, you still can see the metrics that are coming from Grafana and Prometheus. You still can see the traces that are coming from Jaeger. So if you want to see all of them in one place, Kiali can allow you to do that, because you can look at everything in Kiali. All right, so let's go next to the traffic management. Okay, so traffic management is basically like a collection of features that Istio allows you to manage the traffic in your services. So you have different services talking together, and you want to route the traffic from one place to another in a specific way. Then Istio allows you to do that basically. So let's start by the first feature is request routing. So you see that our application has all these services, and it has 3 versions of the review service. So let me refresh, just to keep this feature up to date. Okay, so you see how my application is composed, and you can understand what are the components here and the different versions, and we want to route the traffic to one place or another. So for example, if we want to route everything to the V1 of their services, for example, I want to this one to use V1 as it is now, this one to use V1, reviews to use only V1, and ratings to use only V1. So I can do that either by configuring, by using this YAML file. So I can show you the YAML file. I will. You can apply it by yourself if you want. So let me do get on this one. So it's basically creating 4 virtual services, and every one of them is saying. Yep.
Mohammed, can you repeat what you want to do? I don't understand.
So now, okay. So now I have this application. Product page is using V1. Details service is using V1. Reviews is using 3 versions. And rating is using V1. I want to apply, I want to use V1 everywhere. I want to use V1 here, V1 here, V1 here, and V1 here. I don't want to use V2 and V3. Does this make sense?
Okay.
And I will show how to do it easily with either with Kiali or with the configuration, configuring the virtual services. So using the virtual services, it is basically saying that, okay, I want to create a virtual service, and anything that is trying to go to the product page, I want to send it to the V1 of this service. Same thing for the reviews. I want to use only V1. Same thing for the ratings. I want to use only V1, and same thing for the details. I want to use only V1. So I'm kind of deleting any link with that. So I can do that either using this. Let me use it. Let me do this first, and then I will show you how to do it from Kiali. Okay. So now I created these 4 virtual services that are saying that anything that will happen, it will go only to V1. And let's go here and see. All right, this is interesting. So okay, so let's see what's happening here. All right, so here I'm seeing issues happening here. So let's look at the content of this file again. So it is sending the traffic to V1 everywhere. So I should be able to see only V1 services. All right. So now it seems like it is not able to reach the product details and the reviews and the ratings. So you see, all right. So here it is trying to hit these services. So let me try to resolve this issue. Okay. So I will go to let's say to the rating. So it is not able to get the graphs here for some reason. So if I try to delete this same service, and let's see if the problem persists. Okay, so I don't have this issue anymore for some reason that I. Okay. So we are back to the normal configuration. So now everything is working. So let's try to do that using Kiali basically. So let's go to the graph, and we have the versioned app graph, and I want to so this part, the product page is already using V1, the details is using V1, and I want to implement. Let me just focus on the 5 last minutes. So let's see. So here I'm having this review service that is sending the traffic to 3 versions of the service, but I want to focus only on 1 version. So I can do that either using the configuration or through Kiali here. So I want to create a weighted routing, and I want to send all the traffic only to V1. So if I do that and I create this, let's see what happens. So instantly I can see the changes that everything is going to review 1 that is not getting the ratings at all. Because if you see here, let's go back to the graph. The only version that does not talk to the ratings is V1. So if I send all my traffic to V1, then I will not get the ratings at all. So if I continue refreshing, nothing will show up because I said that I said to Istio, don't allow any traffic to go to V2 and V3, and I want to use only V1. So this is one first feature is if you wanna like route your traffic only to 1 version, then you can easily do it through Kiali. So I'm trying to understand what it is showing here. Okay, so yeah, so this is only a reference to, so this is details, which is the same as this one, and this is reviews, and which is the same as this one. So it's not it is not any issue that I'm seeing there. All right. So so now I have all of them pointing only to this one. So if I refresh a couple of more times, or if I select only 1 minute, I need to see that all my traffic is going only to V1. So all right. So now I'm hitting 100% on V1. If I continue refreshing, it should remain the same, because I'm saying that get me 100% of the traffic to V1. All right. So okay, so this is one of the features. So if I want to route the traffic, let's imagine that V1 is having an issue, then I can create a rule to route the traffic only to V2 and V3. And this is also very easy using the this same mechanism. If I want to update, I can say let's use only V3, and let's say so if I go here, you will see that I will start automatically seeing only the version, the V3 in my calls. So it is pretty fast to apply, and this is one of the advantages of Istio, is that you don't really need to wait a long time in order to see the propagation of your rules. One feature about traffic management also is the fault injection. So this feature is being used a lot in terms of if you want to test the resilience of your system and how your system is reacting to different failures. Let's say if you want to, if your rating service fails, what will happen? If you see that a service is taking so much time, what your services are supposed to do, and how should they react to such failure or latency without having a bad user experience? You need to show an acceptable message to the users. For one way to do it is either by injecting a fault, an error, or injecting a delay. For example, a call will take more time than usual, and we will try both of them. So we have this configuration that we can apply. Let's try to see how to apply that. Okay, so I will put back the traffic as it was. I will just delete any traffic routing. So I'm back to my normal application. So V1, V2, and V3, and now I will try to inject some delay for the rating service. So let's apply that. Let's look at the content of this file and see how it is doing that. So basically, we are updating the rating virtual service. And we are saying, hey, virtual service, whenever this user connects, Mohammed connects, just gives a more delay for any query that he's doing to the rating service. So this is basically what is going to happen. So any other user will not see this delay, because you don't want to apply such a rule for all your users. This will really kind of hurt your experience. But you want to do it as a test environment. So you want to do it in a particular environment, which this is why I'm adding this matching. So basically, what I'm saying, any user that having the end user name called Mohammed, add a 7 seconds delay for the rating service. And any others, just sending any other users without the this header, just send them to the normal service without any delay. All right. Ratings and change it. Okay. Let's see. All right, so if I go to the services here and go to the ratings, so I see that ratings is already changed, and I can look at the YAML of this service. Use the YAML Yeah, and it should show that I have a 7-second delay for that user, and let's see how it works. So now I'm not logged in as that particular user. All right, so let me try. Okay, so Mohammed. Okay, so you see that it is hanging in there. So if I try to refresh, it is taking some time before giving me the answer, which is the delay that is added by the 7 seconds. So it hangs on, like whenever I try to do this, it will take some time. Okay, before saying that the rating service is currently unavailable. So you see that whenever I try, so only if I try to use review one, which is basically not using the rating service, then I will see the results. But otherwise, I don't see any results. So basically here, if I go back in my graph and say, let's go to the review service here, and give all of them access only to review 2 and 3. Action create white. Let's remove this one because it is not. So review 1 is not using the rating service, but I want to focus on the ones that are using the rating service. So I will create that. So now if I sign out, so for some reason this service is not responding to anybody. Okay, so let's see. So I can easily go to the tracing and see where it is hanging. And I see that there is an error in the review service. When it is calling the rating service, it is getting an issue there. And yeah, so this part, I didn't show that previously. So you see that I can also see the logs from the different services. And here I'm seeing I'm getting a 503 from the rating service for some reason. Okay, so if I go back and delete all of these things. So if I go to the ratings, okay, so I have that. I can delete all traffic management and refresh. Yeah, so I see the service going back to normal. So yeah, for some reason it is not applying the. Okay, let's see again this service. Okay. Okay, so I have two destinations here. The first one is the one that will match my my user, and the second one is the one that that will kind of take all of the others, which here it is the destination to V1. So any other user that that is not having the end user header with the exact value of Mohammed should go to the second one. So I'm trying to apply it again and see what happens. All right. Let's refresh again and see what will happen. Yeah, for some reason the rating service is not accepting any calls, except if okay, let's look at its details here. We can look at the YAML from here and ask for any ratings. I'm getting that. Okay, so let's try to delete everything for that particular service and see again. Okay, ratings.default. Okay, so what is this service? I will try to use this ratings.default.svc.cluster.local. So ratings.default.svc.cluster.local. Okay, so I'll jump in here, see if this works. Not yet. All right, so let's jump to the details of this service and try to modify that. View the YAML, and I will use this here. And the hosts are this. Let me try to do this. Okay. Okay. Let's try again and see. Yeah, for some reason it is not accepting the calls even if I'm not logged in. But basically the idea is the same. I don't know why it is refusing right now. Probably for some bad behavior that I have right now, or I mistyped something. But the idea is that you will be able to inject the delays for your services as much as you want. So let me remove that. Same thing. I will remove the configuration of this guy. Delete all traffic. All right. Okay. So now it should go back to normal. Okay. I am here. Yeah, I will give it a try, like the last try for fault injections. Then I will try to do the error management as well, because the same way we can add delays, we can add also errors. So now I have this error again, and I want to be able. Okay, so as soon as I enable, as soon as I enable this this service rating delay, it starts to fail. Probably I'm mistyping some of the configuration, but it should not prohibit us from continuing. All right, so if I sign in, so the idea was if I sign in as this user, I will start seeing delays in my call. So if I refresh, it will just start to hang before giving back this issue saying that this service is taking so much time and it is not available. But it should not prevent us from moving forward with the other users. It should not impact any other user. Okay, so the second thing, like other than adding delays to the service, I can also inject errors. So instead of saying a delay, I want to add an abort. So the same thing I can do is instead of doing the delay, I can modify it and do an abort. So let's apply this one. Let's remove the previous rule and apply this rule instead. Okay, so here I will just I don't have traffic rules here. I will go to the ratings service, remove any traffic thing. So I have same thing, which is samples, book info, networking. So I have I need to abort. So I will apply the same kubectl apply, and instead of doing the rating test delay, I will use the abort, which is exactly the same as that one, but it is doing an abort. So whenever a query happens there, it will abort it and return 500 error message. So for any query for this user, for this particular user, I will just return a status 500. And for the others, I should not do any bad thing for them. So let's see if the same issue is still happening. Okay, so for me, I'm getting directly. So it is not hanging anymore, but it is getting a 500 error whenever I do this call. It is not showing up here, but it is processed in the application itself. So whenever I call that rating service, it will just go and return an issue. And this is like induced by Istio, because we know that the rating service itself is up and running, but this is a rule that is injected by Istio in order to test my application, if my application is ready or not to handle this kind of failures. So it seems like it is ready here. So this is some advantage of using Istio to inject failures inside your applications to measure the to measure the resiliency of the application. All right, so I will go ahead and delete. So even like I have also another feature that allows me to suspend the traffic to this service. So anyone that will call me, he will get a direct issue, because I will not allow any traffic to the rating service. So now, like this service is not accessible anymore. So so I will just. So now this is okay. Let me do that again. Delete. Suspend the traffic. Okay. Let's see. Okay. So now, yeah. So now I don't know why my system is behaving this way. It is supposed to update the suspend traffic. Okay, so now it is supposed to be suspended. So if I just refresh, okay, so now it is working correctly. So now I'm suspending the traffic to that service. So you see, if I refresh, I'm not hitting the service anymore. And if I go to the graph here, I should see that my traffic is trying to hit that, but this service, since it is modified, it is just suspending the traffic. And I'm not seeing an error because the application is programmed to tolerate this kind of thing. So, all right, so you see. Okay, yep. So yeah, so sorry that it is like misbehaving for some reason, but do you have any questions so far for this particular fault injection thing? All right, so then I will just go ahead and delete that traffic rule, delete all traffic routing. So if I delete the traffic routing, and I should start seeing my service working normal, because I basically am playing on the Istio configuration, but not in the service itself. The service itself is still working fine without any issues, but I am trying to understand the behavior of my application if I add delays or failures at any point of the service. Okay, so now I don't have any traffic thing. So yeah, so the one of the next feature that we will be trying to testing here is the traffic shifting, which I showed a little bit of it. Like if we want to apply this, let's say we want to have only V1 service up and running for all of them. Let's see if it will work. Okay, so yeah, I think that I'm having an issue with my system because I tested this yesterday and it was working without any issues. So it seems to be an issue with my original setup. But yeah, so let's try to do that through Kiali. So I want to put all my traffic on V1 first. So I can go to this graph. I can pick up my service, and I can create a weighted routing to put everything on V1. So now this exercise is to imitate a canary release. So a canary release, basically, if you are bringing a new version and you want to test it, then you don't want to deploy it like 100% in your production environment, but you want to deploy it first and start adding more load while you are getting more confidence in your service. So now I have this application. It is only running the V1 service, and I have a new version that I want to test. So I will go ahead, deploy the service. So we know that I have the different versions that are running here, but nobody can see them. I want to test this version, the reviews v3 version, and see if it is acceptable to move on with my users. Then I can promote it if it is successful. If it is failing, then I can just revert back and continue to use the v1. So I can do that through Kiali or through configuration. So through the configuration, it is basically applying the one that I use it here. So let me show you. It is basically specifying how much percentage for each version. And let me copy this. Okay. So basically, if I say if I want to send 50% of the load to V1 and 50% of the load to V3, I can do that through the virtual service configuration, and this is how it is being done. Like you can do it through the YAML file, or you can do it through Kiali. And I prefer the now, like for this demo, I prefer the Kiali way because it is more stable for me, and it is also it uses this visual way to do the things. So I can choose this review service and go here and say, okay, I want to update the weighted routing. So now I'm sending 100% of the traffic to V1, and I want to send also, let's say, a 10%. People start with either 5% or 10% of the traffic, but in order to see that in practice now, because we have a small application and we don't have a lot of load, I will start with the 10%, and I will update that. So like once in like 10% of the time, I should be seeing the red, which is the V3. So I'm keeping like refreshing the browser, and you see that like I saw it once, then like I hit like about 9 times after that, and it was using the V1, and now I see it again. So it's not going to be exactly 10%, but it is very, very close to 10%. So if okay, so now I hit it like twice in a very short time. But overall, like if I do 1,000 times or 100 times, you will see that it is very close to a 10% validation or 10% attempts hitting the V3, and the others are hitting V1. So now I'm just continuously refreshing to see. And you see that most of the time is hitting V1, and some of the traffic is hitting only V3. All right, so this is how you do Canary. So once you validate this and that the version, the V3 is good for your users, then you can go and update your weighted routing, and you give it more. Let's say now I have more confidence in my application, then I will send 50% of the load. So now we should be able to see 50% going to my V1 and 50% going to my V3. So now you see it's almost like the same amount of queries, and we can check in Kiali also. Like let me open that in a different window and go to the graph, and we can show the request percentage. Let me okay, increase that a little bit. So and let's keep refreshing this a little bit and see how much I'm getting. It's gonna be about 50-50. Okay, so now it is 76 and 23. But if I keep refreshing, since I did the change just recently, it should show up something very close to 50% of the time. So it is close now. Now it is I'm sending 55% and 45% to V3. So it is very close to the 50-50 split. And this is how we do Canary. So once we are pretty confident, now we are sure that most of the calls to like 50% of the traffic is going to v3 and everything looks fine, I can go 100% to v3 and suppose that I promoted this version and this is my new version of the app running. And now like all the traffic will be hitting only the v3. I will never see the other versions. And this is how the canary works. Any question about this this process? Okay, so the last thing that I would like to do is the dark releases, and basically, what is a dark release is basically when you start deploying your code, you don't really want so you want to test it in production, but you don't really want to expose that to your end users. So you need to have a way to say that this version is deployed in production, but nobody will see it except a few people. Like my developers teams should be able to see it, but not the others, which is called a dark release. So it is already released in production, but it is dark. Nobody is using it except the ones that you will specify. So for this example, for example, I will use a dark release, and since I am the developer, I will just specify my name. So nobody should see this this new version except me. So let me delete all traffic here. So now we should be able to see all the versions. So if I sign in as my username. So also I should be able to see all the versions. Okay, now I will just do some traffic management. So I will create a matching routing. So matching routing is basically saying that for this match, send the queries to this particular service. For the others, send them to the to other things. So it happens that for this specific application, they have this this header being sent to the rating service. So okay, so to the sorry, not to the rating service, but to the to the review service. So if this header exists and it is exact to Mohammed, so what I will do. So I will send the traffic to v3. And for the others, I'm not putting any match here. Any other should go to v2. Let's say. So now I have two rules. So if anybody is connected as Mohammed, he will go to reviews v3. Any other request will go to reviews v2, or I can also add v1 here. But let's focus only on v2 and v3 for the purpose of the demo. So I will create that. I'm here. Let me sign out. So I'm not signed in as Mohammed. So you see that if I refresh, I'm continuously hitting v2, which is the black stars. So now if I connect as Mohammed, which is the user that is using the dark release, I should be able to see the new version, which is the v3 that I'm hiding or I'm releasing as a dark release for to test and avoid hitting my final user. So now I have a dark release focused, and I can test it. And once I'm sure that this work is ready and valid, then I can go ahead and remove any restrictions, or I can focus on only v3 and open it to everyone.
Mohammed.
Yes.
Juste, comment tu l'as fait pour que Kiali identifie exactement Mohammed dans l'entité de request HTTP? Parce que les headers, on a beaucoup d'informations. Plus que ça, dans le fichier config YAML, par exemple, comment je peux structurer si j'ai plusieurs attributs autres que Mohammed?
Yep, let's put something to explain that. Okay, so let's say I have many. So basically, what is this supposing? This is supposing that I am having different headers that I can use, right? So if I have different headers, let's say I have one header. So let me repeat that again and delete this. And I will create a matching routing. So the matching routing basically uses different things. So either the headers, the URI, the scheme, the method, and the authority. You can specify any one of them. If you are using this in your application, you can specify. So if you have any particular header in your application, you can put it. For example, for this particular application, they are using the end user header. So if you use the end user header, then you can add different users. So let's say we can use a regex. So let's say the end user starts with MO thing. Okay, so anything that starts with MO, then this is my matching rule. I can add different things, like I can add another thing, or let's remove this one and let's end user is exact to Mohammed, and add another match that it is end user exact Ahmed, for example. Okay, so for these two users, I can specify a rule. If I have other rules, let's say if I have another, I don't know, let's say any other header or any other particular thing that I want to focus on, I can add it here. So basically, if you have different attributes, you can specify them in the matching selector here. So this is how you can do the dark release. So you can use many. It's not one-to-one mapping. You can use different attributes here. But once you specify that, then you will need to add the rule. What is the rule? So if anybody is respecting these matching selectors, then where do you want to send it? To V1, V2, or V3. Let's say we want to send them to V3, all of them. Now we have, like, we know that anybody that will arrive here with these headers will be sent to V3, and we want to add another match which will cover all the other users. So we want to send them to V1. Okay, does this make sense, Ahmed?
Ok, c'est bon, j'ai bien compris.
Okay. So now we have these two things. So if I log in as if I'm not logged in or logged in with a user that is different from Mohammed or Ahmed, if I refresh, I should only see V1, which what I specified. So now let's sign in as any of these two users. So if I do Ahmed, I sign in, I should see directly the V3. If I sign out and sign in as Mohammed, I should see V3. This is what I specified in the rule. So actually it's not applying that here. So in this update matching rule, okay, so it applied only your configuration here. So if I okay, and I can move it up and down here. So if I add a match here, let's say end user, you can say if the end user header is existent. So for example, if this is present, let's remove this one and say that if the end user header exists at all, then I want to send it to V3. Otherwise, I want to send it to V1. So anybody who is logged in, I can send it to
محمد خلاص كان شوفاج صالح. محمد
Ahmed, please put yourself on mute.
محمد خلاص كان شوفاج قادي.
Ahmed, please put yourself on mute. All right. So let's say
excuse me.
Yeah, no problem. So let's say we have a rule that anybody who is logged in, we want to send him to V3. Anybody who is not, we will send him to V1. Okay. So let's update that and say. So now let me sign out. I'm not logged in, so I need always to see V1. Now I will sign in with any user. and automatically I start seeing the v3 because I specified this attribute of existent. I'm not really doing any search based on that. And this is so this is how you you manage the access to your different versions and do dark releases, canary releases, and so on and so forth. Any questions about that? Yeah, if there are no questions, all right. Okay, so now let's go back to the original version, and yeah. So if I remove these versions, and I will go back to the normal to the normal application setup and start seeing the normal features here and there. Yeah, and I will go back to my initial configuration. Yeah, so this is basically how it is being done. I got some issues with my setup, so I don't know what happened when I tried to inject the faults. But other than that, we saw how to do the request routing, the fault injection, the traffic shifting, and how to do dark releases. So this is about it. This is what I want to share with you today. So feel free to go through the quiz and practice these questions. Feel free to deploy Istio in your environment and follow the steps that I did, and you should be able to reproduce that without any issues. If you find any issues, just ping me and try to reach me on my email or on LinkedIn as well. Okay, so I will not take the quiz. All right, so as you know, this is the last session of this course, and for me it was a first experience, and it was a fun journey. Just to share some of the DevOps techniques and technologies. So as mentioned in the beginning of the course, the objective was not to make you expert in all of that, but it was basically to introduce you to these technologies and to make you aware that they exist and that you can get a lot of advantages of using things like CI/CD and service meshes, Kubernetes, and containers, and so on and so forth. So I hope that you learned a few things, and this is like a teaser for you to go and learn other things and kind of sharpen your skills and build your DevOps career. And every section of these of the ones that we saw requires a lot of more knowledge and more work in order to be an expert in them. And you cannot do that without hard work and continuously trying to learn and failing and learning again. So feel free to try things out. If it doesn't work, try to find solutions and reach out to the community. Try to reach out to me or to anybody of the Horizon team. We will try to help you out there. Yeah, and this is only the starting point of of building your career. So feel free to take the quiz that is following this section. It covers all the different sections that we saw together. And if you have any feedback, please feel free to share it with me, and you can continue using this course and this platform.
Bon, Mohamed, je vous remercie beaucoup pour cette formation. C'est très intéressant et vraiment vous montre la
So let me stop recording.
You are a professional